Ladies and gentlemen of calculus, good morning. Good to have everybody here today. We're going to work today on note cards 24 and 25. First one, increasing, decreasing functions, and this is really just a definition. And you remember last time I unveiled this little diagram here, F prime, F double prime, remember that?
Yeah.
We had plus, minus, and increasing, decreasing, and this concave up, concave down, and beneath it we had this. And what's happening is that this graphic here, and lastly under F double prime, and what happens is if F prime is greater than 0, and here we have F prime greater than 0. You see that plus sign?
Yes. I know. You're killing me, Mr. Steve.
If F prime is greater than 0, then that means that F is increasing for all x in that interval. And so there's the linkage right there with the diagram. And then likewise, if F prime is less than 0, then F is decreasing for that interval. So that's the relationship.
Oh.
So this diagram helps us see the relationship. So it's a graphical organizing representation of this law here. And so really that's all it is. So let's go ahead to the next thing here. And that just gets us right to a table. The derivative g prime of the function g is continuous and has two zeros. Selected values of g prime are given in the table below. If the domain of g is the set of all real numbers, then g is decreasing on which intervals? Remember that you can use that little diagram that I drew here. And that's one that you should be able to draw from memory just really quickly, like on your tests and so forth. Make a little sketch of it. Then you have it right ready at hand. So based on this, what interval or intervals is g decreasing?
Negative 2 and 2.
Okay, and Aaron says negative 2 to 2. Okay, is that correct? Is that Chris? Okay, that is correct. So what is our justification? Because
Well, those are negative.
because g prime of x is less than 0.
Yeah.
Okay, on that interval. So that's it. Now it's a bit of a trick question in that it says decreasing on which intervals. Well, actually it just looks like one interval here, right? But that's that one. Does that seem that hard of a concept to deal with?
No.
Does it help to remember this relationship here? Okay, the plus minus. You see how quickly I'm drawing this, right? Okay, and then plus minus. That was 20 seconds of drawing, wasn't it?
If that.
If that, yeah. So this is exactly what we're talking about right here. We see G prime is less than 0, meaning that that is the interval over which G is decreasing. Okay? So that's really it. And again, this is a real AP test problem as designated by the asterisk here. Okay, and now we have for 2 and 3 identify intervals on which G is increasing and or decreasing. And then it also shows, basically 2 is one where it's a calculator exercise where you graph this and then you figure out G prime and put them simultaneously in the calculator and see what is happening there. You have your calculator?
I don't have
You don't have your calculator?
it. I forgot it. Because I have to charge it and then forgot it.
What you do is bring it in here uncharged. We can be charged here. I got a charging cord and everything. And is your calculator charged? Good job.
Charging up.
I don't know.
It has to be away.
What did you say, Gavin?
How do you check the battery?
How do you check the battery? Is the thing working?
It's on, yeah.
It's on, it comes on. I don't know the 84s how you check the batteries really. You just get a battery warning. To me, to check those batteries, what you have to do is get a little battery strength checker and remove the batteries from them to be sure about it. But what I do, if you're concerned about it, bring some extra batteries with you when you're taking the test. Okay, so now we go here. It's x to the 4th minus 8x squared plus 1. So we have x to the 4th power minus 8x squared plus 1. And when I zoom 6 it here, we're going to have that. And so can you see where the function appears to be decreasing? Looks like from negative infinity to 0 and increasing after that. And so we take the first derivative of that, and what's going to be the derivative of that? 4x cubed, right?
Did you put times 8x squared instead of?
Oh, did I? Okay, well then I got that wrong. Before I go ahead, it should be plus, right?
Minus.
Should be minus, okay. Yeah, well then I got that, then that's really wrong, fundamentally wrong. So this, let me go ahead and get rid of this one here. So that's what it looks like. Okay, thanks for correcting
I'm
that.
gonna say that's not what I got.
Yeah, no, thanks for correcting that. Appreciate you doing that. So here we have 4x cubed minus 8x squared, 16x squared, excuse me, right?
What did you say, 16x?
16x.
Is it
16x.
4x cubed?
4x cubed is what it should be. Man, I got this wrong all over the place.
All right, Mr. G.
Let me just do this first. Delete. Oops, I gotta delete up here. Delete, and then this needs to be cubed, right?
Yes.
And then it would be good. Okay, so now we have it. Okay, so we have below the x-axis f prime below the x-axis, and over that interval, what's f doing? Decreasing. And we get above the x-axis, what's f doing? Increasing. And then we have below the x-axis decreasing, and then we get over here above the x-axis, we have the red one is increasing. So you can see, of course, and then you can tighten up a little more. If you take the window, you might be able to see it a little better if you do this. Negative 20, 20 maybe. I don't know. Probably be able to see it a little better. Yeah, you can see it a lot better actually. Okay, so that's the relationship. And to me, I just have a hard time piecing those things together, except, and so what do I use to sort out my understanding of this? What do you think I use to sort out my understanding and make sure I see what's going on and get it right? What do I use? That I've told you that
One.
that's a number line, the friends, yes, Gavin. Yeah, Gavin, all right, Gavin.
I was thinking of the whole thing. I wasn't sure.
No, huh? That's good. That's good. I like you be thinking that.
What?
You find out who your friends are.
Okay.
The country thing?
So now,
I don't know.
here we have 3, and by the way, for number 3, you have G prime.
You're gonna tell me.
And it says, here, I want you to go ahead and figure out on problem 3 here, whose graph is shown, where the increasing, decreasing intervals are for that one, for number 3.
Tracy Lawrence. So.
Okay, have you figured it out yet?
I think so, but I think I could be wrong.
Okay, let's see here. Again, what Gavin suggested, I want to go ahead and put this here. And where are the critical numbers? Negative 3 and at 2. And here we're going to put G prime up here and G down below. And what goes here to the left of negative 3? Is G prime positive or negative to the left of negative 3?
To the left?
Negative. So that means that we're decreasing this interval. What about all these other intervals? Plus and also plus, right? So increasing, increasing. So over what intervals is, for number 3, is G increasing? G is increasing on which intervals? On what? On negative 3. Now, it's a matter of debate here, because since G prime only apparently goes to 0, you could make the argument that actually this as an entire single interval is increasing.
Why is it increasing on negative 32?
Pardon me?
Because it's above the.
Above the x-axis here. And G is decreasing on negative infinity to negative 3. Yeah, and so, but to me, this is a good example of why the number line is so helpful, because without if you think about it a little bit, it can set you straight, but it defies intuition a lot. At least that's what I find in my case.
Intuition.
So That's what we do with tools analysis. We use mathematics to get things correct. Okay, this brings us to our next note card, which is finding increasing and decreasing intervals. It's very much related to note card. Okay, note card 25. Okay, it says find the critical numbers, set up test intervals. And so basically these instructions that are given are things that we've already had some experience doing, right?
Yes.
We've done them today, we've done them for how long now? 2 weeks? It's been a while now. Okay. So, first step, of course, find the critical. So since you have experience with these steps, I want you just to do problem 1 right here, and we'll go over it in a minute.
Yes.
Problem 1.
Problem 1.
Problem 1.
Find the critical numbers. That's step 1.
Step 1, find critical numbers. And you know what critical numbers are. Gavin, I know you know what they are.
Thank you.
You know what they are.
I remember.
Okay, so I imagine you have to do this. Aha, I think I got the critical numbers.
Great. And then you go use those critical numbers to go to the next step, right?
I said I think.
You feel the same as mine.
Where's...
I'm not giving you alpha information. Snake.
Well, why would I give you my information?
I actually have them.
Mm-hmm. So, step 3, find the sign of f prime of x for each interval. Okay.
Not scared of you,
Better.
but. Yeah.
Okay, these are the critical numbers I got. I'm not 100% sure it's right, but that's kind of what I'm looking at. Is that what you got? Gavin, is that what you got? Okay, the next thing. 0, 1. And here's our f prime here, here's our f underneath, right? And to the left of 0, we have, is that negative, negative? To the left, so we have positive, right? And then between 0 and 1, that would be positive and that would be negative. And then greater than 1, we have positive, positive. So then, so f is decreasing, or f of x is decreasing on which interval?
Decreasing from 0 to 1.
0 to 1, because f prime of x is what?
Less than 2.
Less than 0. And f of x is increasing on, looks like, is that negative infinity? 0, and then 1, infinity because f prime of x greater than 0. Was there anybody who had trouble getting that? Shouldn't be that much trouble, right? Okay. Let's see what came up here. Yeah, I think it's all there. Okay. Let's go on to this. We have another one. I want you to work this one out. Problem 2.
Know which ones are increasing.
Yeah, just increasing in this instance here. I see some right hands going to work. A lot of right hands going.
My right hand is always working.
Shut the.
Oh, wait. That's something funny. Not like that.
Good morning. Welcome to room 15 where learning comes first. Most of the time. No, I'm not. Are you trying to outline veterans for Veterans Day? No, I'm not. I'm glad you think I might be one anyway. Thanks. Bye-bye. Bye. I just had to make the confession, the sad confession, that I am not a veteran.
You're not?
Not a military veteran. That's what she meant. I'm a veteran of the teaching profession.
Not yet.
I'm a veteran of the oil industry,
Oh, really?
oil and gas industry. Yes, I
That's
am.
what it is.
Oh, you say I'm not a veteran of the teaching profession yet?
Oh, you're still a teacher.
So if you're,
Once you retire, you will be.
so that's the definition of veteran?
Mhm.
Okay. I think that as a technicality, I think you're a veteran, because what happens is, when they talk, says who are the veteran teachers, like, who are the experienced, so they're
Well,
different.
I guess so.
Yeah, so it's a little ambiguous, but I see what you're saying.
It depends, I guess. I don't know, it just depends on what your definition is.
Yeah, it is, so there's a little ambiguity in the definition, but I see what you're saying.
Yeah, I see what you're saying too.
Mr.
Yes, did you work this out?
Well, I got like the factoring,
Uh-huh.
but this guy right here doesn't exist.
Well, it doesn't exist?
Yeah, because it'd be the square root of a negative. So you just find this one?
No.
Okay, well, okay, let's work this one out then.
Or I might be wrong.
What?
Did everybody else work this out? Aaron says he's kind of has a question about something. Anybody? Okay.
That's your time.
So here, the first step, right? F prime of x is equal to 4x cubed plus 2x, right?
Yes.
Is that it?
Oh.
So 0 is equal to 4,
Oh, minus 2 up there.
no, 2x, excuse me.
Freaking idiot.
0 is equal to 2x, and then we have x squared plus 1, right?
2x squared plus 1. But yeah.
Squared plus 1. Oh, 2x squared, yeah, 2x squared plus 1. Okay, and then this is this always going to be positive here? Yeah, it is. I mean, or 0. Cannot be 0. It's going to be positive, no matter what. So what is our only critical number here?
0.
0. So x is equal to
Okay,
0.
so it's just the only critical number is 0.
Yeah.
Okay.
So 0 being our only critical number, we put f prime up here and f below. And then so you just, now you know this is always positive, and this is just going to be negative over here. And so we're going to be decreasing here and increasing here. So what is our answer to this? F of x is increasing on 0 to infinity. And again, our justification, because f prime is greater than 0. And then x to the fourth plus x squared minus 2. I'm just going to put that in the calculator.
Oh,
So x to the fourth power is plus, was it x squared? And is it plus 2?
Minus 2.
Minus 2. So we graph that, and we see exactly that, don't we? Increasing from 0 to infinity. So that's it. And what else do we have here?
Shut up.
Again, we're talking about polynomial functions, which shouldn't be that. So here's one where we have it different. So we'll leave it, I want you to do this one here, and we will leave it here today, and we'll finish talking about this one tomorrow. That will get us through note card 25. We start on note card 26 tomorrow. Okay, you working on this problem here? Yes? Carson, yes?
Those-
Gavin?
Why did
Yes.
you continue?
not to. I'm leaving. That's not going.
Leave it for future reference.
I think on this one here, when you set that equal to 0, I think you end up getting where the function is undefined.
That's what I was thinking.
Mm-hmm.
Yeah.
So what does that mean?
Well, you still got to draw your number line. It'll be the same. You'll mark that place, x equals 2, on your number line, and you'll still make your analysis on each side to see if that's positive or negative. So it'll be the same type of process, other than you don't find x equal to 0, you find x undefined. At x equals 2.
I think I get it.
Yeah. So, anyway.